and they are essential in providing access to applications. You can use OC port forward to port forward traffic to a specific pod instance, but OC port forward is really for troubleshooting, and that's not something that you are going to use as a structural solution. The structural solution would be the service where you run a service and the service is doing the load balancing, is providing the unique entry point to the pods. Nice thing about the service is that it lives in the API, in the etcd, and as such it automatically picks it up if more instances of pods have been added or removed. So services connect to endpoints, that's how it's called in the terminology, and the endpoints are pod individual IP addresses. Ingress in Kubernetes is a resource that exposes services to external users, but Ingress as such is not really used in OpenShift. OpenShift is using routes as an alternative to Ingress. Just to make it easy for yourself, routes and Ingress are pretty much the same, but they are different API resources. And where we have seen that sometimes OpenShift is picking up API resources from Kubernetes, that is not something that has happened for the OpenShift routes. So OpenShift routes is what you need to be able to work with. And the route is something that sits on top of a service and that allows you to load balance traffic to different endpoints. So it's two different steps. First step, you create a service. That is something, by the way, which you know is done automatically if you use OC New App. Once you have your service, you manually create the route using either OC Expose or OC Create Route. Good. Let's first talk a little bit more about using services to access the pod. So the service is used as a load balancer that provides access to a group of pods that is addressed by using a label as a selector. And services are needed for pod access as pods are dynamically added as well as removed. And services are using labels and selectors. And when you use OC New App, a service resource is automatically added. Let's see if we already have something that makes sense. So I'm using OC Get All in my current context. And what do I get? I am looking for services, and let's do this on BGNX, for instance. So if I use OC describe, let me first do OC completion, source smaller than OC completion bash. And then let me use OC describe on the service BGNX. Then what do we see? We see that the service has a label. The label is app is BGNX, and it has a selector, and the selector is deployment is BGNX. So if I use OC get all -- show labels, I want to talk about these labels a little bit. Then we can see right here that this app is BGNX is present on the deployment. On the replica set, we can see deployment is BGNX, and on the pod, we can also see deployment is BGNX. It's funny to see that OC New App takes a slightly different approach in the use of labels as what you will find in Kubernetes. In Kubernetes, if you use OC Create Deploy, then the deployment as well as the replica set as well as the pods are all getting app equals name of the deployment. In OpenShift, that's not the case. As you can see right here, the deployment is getting app is name of the deployment, but the resources below that are getting deployment is name of the deployment. So that is what the service is using. We can see that the service has these endpoints. So the endpoints are 10, 2, 17, 0, 39, which is the pods. And you know what? If I use OC skill, not OC get skill, just OC skill deployment, BGNX, -- replicas is 3, then my deployment is getting skilled. And if I do my OC describe again, then we can see what? Well, we can see that apparently We caught it in the middle of the process. Now it is done. We can see that right now there are 3 endpoints. And what is going to happen if I would use OC edit SVC bgenex? I'm going to edit the service, and I would like to introduce problems. So let's make that deployment bgenex with an uppercase. Here we go again. Let's give it a few seconds. Because the Kube controller manager needs to be able to pick up the changes. And let's do another OC describe. And what do we see in OC describe? Oh no, we see the endpoints are gone. This is a simple demo. In this simple demo, I just want to show you how important the role of this selector label is. The fix is as easily done as the problems were created. I am going to change deployment to bgenex with a lowercase b. And there we go. And one final check, OC describe, and it's picking up the endpoints immediately again. Now, this is demonstrating how selector labels are creating a relation between the service and the pods in the backend. If you involve routes, it's the same story. So if for some reason your routes cannot pick up the appropriate pods, this is the line of troubleshooting that you need to apply. Good. Let's talk about these routes a little bit more. So what about these routes? I'm back on the slide, by the way. Managing the Ingress resource. Why do I talk about the Ingress resource? Well, in the end, because a route is an OpenShift implementation of Ingress, so I might as well use a generic terminology. So Ingress traffic is generic terminology for incoming traffic. And as such, it's more than just Kubernetes Ingress. And the Ingress resource in Kubernetes, and here we are specifically talking about Kubernetes, is managed by the Ingress operator, and it accepts external requests that will be proxied. And the route resource is an OpenShift resource that really provides the function of Kubernetes Ingress, but more. This is, by the way, this smells a little bit like RedHat marketing. Now, let me un-Red Hat market it a little bit. If you look at the Kubernetes ecosystem, in the ecosystem, different Ingress resources are provided. And really, you can't say that OpenShift routes provide more functionality than Kubernetes Ingress, because there's no such thing as Kubernetes Ingress. Kubernetes Ingress is a generic framework, and in that generic framework, most of the Ingress resources are operators, are separate applications that are installed in a Kubernetes environment, and it really depends on the type of Ingress that you are using, which type of functionality is provided. But hey, OpenShift routes can be seen as an Ingress operator, can be seen as an OpenShift route. Let's just try to understand what these things are doing. So what are these features? Well, TLS handling is very important. OpenShift routes can do Tls Re-Encryption. What does that mean? That means that incoming traffic is sent to the route. The route for the end user is an endpoint. The end user is not aware of anything that happens after the route. And of course, you want to send the traffic to the route in an encrypted way. Then from the route, the traffic needs to be regenerated and sent forward. And that is what Tls Re-Encryption can do for you. So you encrypt twice. Then we have Tls Passthrough. In Tls Passthrough, the route is not the endpoint for the TLS communication, but the route is setting the traffic forward to the application in the back. Now, routes can also do split traffic for blue-green deployments. Now, blue-green deployments is a generic solution that can be implemented at so many levels, and routes are just one of them. Now let's try to understand what the route is doing. So route resources are implemented by the shared router service that runs as a pod in the cluster. That again is something that is true for all of the Ingress operators that you are using. There's always a pod involved, and this pod is always taking care of the traffic handling. Because in the end, if you need specific functionality to be aware in your cluster, well, the functionality needs to be running as a program, right? And in order to run functionality in OpenShift as well as Kubernetes, the pod is going to be the solution. Now, the router pods bind to the public-facing IP address on the nodes. What does that mean? That means that these router pods provide external accessibility, as long as the nodes are externally accessible. Let's make no illusions for what we are doing in this class. In this class, we are working with OpenShift Local, aka code-ready containers. And this OpenShift Local is not reachable from the outside in any way. In order for routes to work correctly, DNS needs to be configured. And then we are talking about internet DNS, because in the end, the traffic flow starts with the user trying to access your application. So the user is generating a request based on the DNS name of your application. And in DNS, you don't want to update the provided DNS with every single application that you are creating. So in provided DNS, you need wildcard entries. star.myapp.com, something like that, in which star is resolved to anything. So anything that is sent to myapp.com will go to this DNS wildcard. Routes can be implemented as secure and as insecure routes. Now, insecure routes is something that we will have a look at in just a little bit. It's also something that you have already learned in EX180 if you've taken that class. Secure routes are one of the big topics in EX280. And most people who fail the exam fail because of something that relates to the secure route. So I'm going to spend significant time on making sure you know how all of this works. Let's talk about requirements for creating routes. So route resources need a couple of values. They need the name of the service that the route accesses, because a route is really exposing access to a service. They need a host name for the route that is related to the cluster DNS wildcard domain. So the host name, that's a little bit confusing, but the host name is included in the route. The route is really behaving as if it is a physical host, and that is where you set the host name. And this host name must be reachable if you want to do this for real by the external DNS wildcard domain. You need an optional path for path-based route if you want to further differentiate. We're not going to do that in class today. You need a target port, which is where the application is listening. That is the same in services. If you create OpenShift or Kubernetes services, the service is really doing port forwarding. And in order to do successful port forwarding, you need a target port. So that's the same for routes. And you need an encryption strategy. And this encryption strategy determines how you are going to deal with your TLS certificates. That will prove to be a big thing when we are going to explore these routes. And last but not least, routes like services, as we have just seen, need labels that can be used as selectors to send the traffic in the right direction. Now, you should also notice that the route does not really use the service directly. It only uses the service to find out to which pods it should connect. So it's not as if the traffic flow goes from a route to service to pod, the physical traffic flow. The route discovers which pods are available by communicating to the service. And once the route knows which pods are available, the traffic flow is going there directly. Now, while working with routes in OpenShift, there are different route options and types to consider. You can use secure routes. And secure routes can use different types of TLS termination. There is 3 of them. First, there is edge. Edge is where certificates are terminated at the route. And if you want to configure edge, the TLS certificates must be configured in the route. Edge traffic termination is actually quite common. The idea is that the user has communication to the route. So that is where you want to have some security. And from the route to the end pods, it's not as important anymore because you are not in a public network. From the route to the pod is handled by your OpenShift infrastructure. And this OpenShift infrastructure is not inherently as insecure as the internet. If you want a higher level of security, you can also choose to do pass-through. Pass-through is where termination is happening at the pods. And that means that the pods are responsible for serving the certificates. And you need to use this to support mutual authentication. So it really depends on your application. What you need to know is where you are going to work with your TLS certificates. That's a fundamental distinction. So in Edge, the certificates are available on the route. In pass-through, you don't have to configure any certificates in the routes. You need to make sure that the certificates are available in the pods. So pass-through and Edge is a completely different procedure regarding certificates. As we will see, we will have a look at both of them. Re-encryption is really a combination of both of them. Re-encryption is terminating traffic at the route first, and then new encrypted traffic is established with the pod. For your EX280 exam, make sure you know how to deal with Edge as well as pass-through. That is what is really important. And last, there is the insecure route. Insecure route requires no keys or certificates at all. Let me demonstrate how to use insecure routes. It's very easy, in fact. You just use OC expose followed by a service. In the insecure route, and this is typically something that you might be asked for on the exam, in the insecure route you have an option to set the host name. If you do not set the host name, then by default the host name will be name of the service hyphen name of the namespace dot name of the cluster. If you don't want that, use -- hostname to expose the hostname. And obviously, but that is not a part of your EX280. If you want this to work, you need to make sure that DNS is set up correctly as well. So as just mentioned, if you don't specify a name, then the name, a route name, .product name, .default domain is used. And notice that only the OpenShift route and not core DNS knows about route names. Core DNS is internal OpenShift, and in internal OpenShift, service names are used to communicate between the different services. Routes is for external accessibility, and that means that these route names are really internet-facing. Let's have a quick look. So on the demo system, I'm doing an OC get SVC. There we can see BGNX. I do an OC expose SVC BGNX. And there we go, we get the route. And if I use OC get routes, comma, SVC, then what do we get? We get the route, and the route is the name bgnx-sccs.apps-crc.testing, and that is exposing the service, and the service is on the port 8080, and that is how it is working. So if I would use curl to bgnx-sccs.apps-crc.testing, then we get a welcome to Nginx. So this route name is automatically picked up by my client. You can start using it directly. You don't have to worry about any ports or whatsoever. Now, interesting in this is OC describe route as BGNX. I want to see what is going on. And let me put it on top of the screen to make it more readable. What do we see here? We see that it has these labels. So the label app is BGNX, and this label app is BGNX. That is how it is getting in touch with everything in the background. So we have a service BGNX that is identifying the service that was found based on this label, and we have the end. And to make services accessible, routes provide DNS names. And OpenShift has an internal DNS server, and this internal DNS server is reachable from the cluster only. And to make OpenShift services accessible by name on the outside, wildcard DNS is needed on the external DNS. And again, folks, this wildcard DNS is on the external DNS. That's not a part of the OpenShift configuration. That is a part of the provider infrastructure, and for that reason is no further developed here. Now, external DNS has wildcard DNS to the OpenShift load balancer, and the OpenShift load balancer, which is the route, provides a front end to the control nodes, and the control nodes run an Ingress controller that are a part of the cluster, which is the route, and that makes that through this system you get access internally. All right, JD is asking in the exam, in case they ask to create a secure route